Hello friends, I welcome you all to this session on numerical methods using C++ programming. So in this lecture, what we'll do is, we will try to write code for Simpson's one-third rule. And the code is going to be very much similar to the previous one with slight amount of deviation. That's it. The maximum amount of the code will remain the same. So in trapezoidal case, you have taken individual trapezoids and then added the area. So here what we do is, we don't take individual trapezoid. Instead, we take area of two strip at once, and area of two strip in such a way that we fit a polynomial there of second power. So if you don't want to go into that detail, then you can club these two, think that we are clubbing these two and we are getting this area. That is fx naught plus 4 times this plus fx 1 divided by 3, because 3 data points we have taken, and then times h. You can think in this way. Now one more thing, very important. This n, it should be even. Why? Because first we will be taking this strip, okay, these two, then we will be taking these two, okay, and then we will be taking these strips. So if we don't have even number of trapezoids, then what will happen? Let's say only 1, 2, 3 trapezoids are there. So this will be okay. 1, 2, and 3, 4, and then 5. So what will happen? One trapezoid will remain. So the better option is to always take n as even when it comes to what we say, this Simpson's one-third rule. And then if you add up everything, you will be getting this particular formula. This part is very similar to the trapezoidal rule, and here this is summing for only the indexes which are odd, and this is summing for only those indexes which are even. These, not this one, only even. Now inside the trapezoidal rule, what we'll do is, we will write the logic for this only, and at the end, when we multiplied s by h by 2, we will multiply it by h by 3. That's it. This is the only difference. So let us do it. So this is the program. Let's say I'm interested in finding out the integral of sine x from 0 to pi by 2, having 10 data points only. This is 10 is even. So if I run it now, so I am getting an answer of 0.99. So if I let us do what? Let us reduce it to 4. So the answer is 0.987116. Now what we'll do is, we will write the same thing but for trapezoidal. So what is the difference? This is no difference. This will remain the same. This will remain the same. Creation of x will remain the same. This is also same, because if you look here, it is fa plus fb. So this will remain the same. Now inside this, we have to do some juggling. So now what we'll say, look, if it is even, if I is even, so here, then we have to multiply 2 to fx and then add. Okay, so we will say, where is the code? This. Inside, we will say if I is even, that is, if I modulo operator 2 is 0, then we have to do this. Okay, whereas else, if it is not even, then it has to be odd. Then you have to add 4 times. So you look here again, if I is even, then 2 is multiplied, and if I is odd, then 4 is multiplied, and that is what we have written here. If I is even, 2 is multiplied, and if it is odd, then 4 is multiplied. And then outside, we are not multiplying h by 2, instead we are multiplying by h by 3. Again, look, h by 3. So if that is the case, and if I run it now, then I am getting an answer very close to 1, just only using 4 strips. Okay, so if I increase the number from 4 to, let's say, 8, then it is very close to 1. Now you can see the power of Simpson's rule, because if you go into the detail of mathematics, then polynomial second power is fit basically here, and that will result into this particular area. So that is the reason why this method is more powerful, as the error reduces a lot. So that's all for the Simpsons rule. So thank you very much for watching this particular video. In the next lecture, we will try to um, do some more on numerical methods. Thank you very much.